So this one's a real algebraic one. So it gives us the equations of motion. We've got x double dot equals minus kx dot, and I'll do it over here, y double dot equals minus g minus k y dot. All right, so we have to find x dot and y dot, and then x and y. So we're just looking to, and both those expressions that we're given here have t in them. So we can use the fact that acceleration is the derivative with respect to t of velocity. So you can see here, I'm going to put the x on this side with the dx, the x dot with the dx dot, I should say. And then we've got minus k dt, so t is between 0 and t, so we'll just say minus kt. So here we're going to have, let's put minus kt on this side. Sorry, I can't write very nicely. All right, so we're going to have the integral of 1 on x dot with respect to x dot. So when we do that, we of course get log, and we're putting in, remember, x dot, the initial, so initially we've got a velocity of v. So initially, and this angle is alpha. Sorry, I didn't put that in first, so read the question. And so initially we've got v cos alpha horizontally for our x dot, and v sine alpha for our y dot. So here we're going to go from our x dot original or initial up to our x dot. Now the pen's going to stop working soon. So when I sub x dot in, I'm going to get x dot, and then I'm going to go minus, so it's the same thing as doing that. The initial, which is v cos alpha. All right, so you can see if we exponentialize both sides, we're going to get x dot on v cos alpha. So let's put the v cos alpha over here. So we get x dot equals v cos alpha times e to the minus kt, which is what we wanted. So that's up there. All right, so that's how you get that one. So if I'm doing double dot, just remember that that is the same as dy dot dt. So that's, I might put the minus outside a bracket to make it easier. All right, so again, I'm doing two things at once. I'm going to, so the right hand side with 1 to t will just be 0 to t, so that's t. And on the left hand side, which I'm changing to my right hand side, so I'm going to have this g plus ky dot on the bottom, and I'm doing with respect to the y dot, and I need a k at the top. Oh, I've got a minus as well, so I'm going to put a minus, so the 1 on k out the front. So just rearranging it, and again I'm going to start with my y dot 0, that's y dot 0 up to my y dot. So 1 on k, I'm going to have log of the bottom, but I'm subbing in y dot. So I've got g plus ky dot, and then I'm subbing in the original, so k, and it's v sine alpha from our original velocity here. All right, so if I put the minus 1 and k on the other side, so I get minus kt and exponentialize, then I've got that g plus k dot on that g plus kv sine alpha. So you can see that, let me just move it along a little bit. All right, so if I times and put the, so I've got g plus kv sine alpha times by e to the minus kt. That gives me that g plus ky dot. So I want to minus g from that, and then divide by k to get y dot. So I'll take, I'll look at this first of all. So I've got that, I've got all of that, and I want to minus g, and then I want to divide everything by k. So you can see, if you want it in the form they've got it, I'm going to divide the bracket part of the first term by k. So I've got a g on k and a v sine alpha. So I've divided that first term by k and then divide the second term by k. There we go. So we've got it in the form they wanted in. So if I go back, right, so that's that form there. All right, so then we're going to do the same thing to get the next equations. Okay, so I don't need any of that. So let's go ahead and get the next equations. So if I start with this one, x dot here, so remembering x dot, so that's just dx to t. So that's v cos alpha e to the minus kt. So if we integrate 1 with respect to x from 0 to x, we're going to get x. If we integrate v cos alpha e to the minus kt with respect to t from 0 to t, you can see that we are going to get, all right, so we'll still get e to the minus kt between 0 and t, but we need to divide by a negative k. So I'll put a negative k there. And you'll also see, so I can actually use that negative by swapping, so we use that negative up by changing these limits. I'm going to sub in 0 first, so where e to the 0 is 1 minus, now I'm going to sub in t, so I go e to the minus kt. So it takes care of that negative. All right, and that is what we wanted. Yes, great. So we're going to do the same thing with the y dot. So the y dot is just dy to t. So we've got g on k plus v sine alpha, lots of e to the minus kt's minus g on k. So we'll integrate y. We'll integrate 1 with respect to y, which is y. And then, because we're going from 0 to y. And then we've got this whole bracket here, g on k plus v sine alpha. So we're integrating e to the minus kt with respect to t from 0 to t. And then we're also, so that's the first term, so we'll also do g on k with respect to t, or 0 to t there. All right, so I just broke it up into 2. So we're still getting, so again, we get that e to the minus kt, and we've got a minus k that we have to divide by. So what I could do is actually not divide by the minus k, just divide by the k and swap the limits again. So if I do that, I'm going to have g on k squared and v sine alpha on k. So I've divided by that. And then I'm going to sub in 0 before t. So e to the 0, so 1 minus, and then e to the minus kt. So that's the first one. Minus, here we've got g on k, and this one we're subbing in t first, so t minus 0, so t. And that is what we want, right? Yeah. Okay, so that's B. So then lots of algebra, lots of practicing. So C, we have when the particle reaches its greatest height. Now we know when it reaches its greatest height that, since we've already got the equations up here, I'll rub those out. So greatest height we know happens when y dot equals 0. So we usually find the time when y dot equals 0 and then sub it in to find the horizontal distance, which is the x. So we sub it into x. So if we do that, let's look at the y dot. Where's our y dot? Is up here. So if we make y dot equals 0, you can see that g on k will be equal to g on k plus v sine alpha e to the minus kt. So I might make e to the minus kt the subject. So we've got g on k divided by g on k divided by g on k plus v sine alpha. So same, if I just times that by k there we go. It will, because they'll be then both over k, I can just get rid of the k. So it's like you're doing this, making that k there on k there. So I'm dividing by on k. So these k's can go, and I've just got g on g plus kv sine alpha for e to the minus kt. I'm going to leave it there instead of making t the subject because I know that the x equation has e to the minus kt in it. So I can substitute it straight into there. So let's do that. So we've got x equals, we've got the v cos alpha on k, and we've got 1 minus, and that 1 I might make, because I'm going to be minusing g on g plus kv sine alpha, I might make the 1 g plus kv sine alpha on g plus kv sine alpha. So just so it's easier to do. So you'll see that, and it was a minus there. That's not great, does it? So let's actually just make that a common denominator, and that's sine alpha there. So you can see this is going to have a g minus g, so I'm just going to get a kv sine alpha on top of there. So on top, you'll see I'm going to have this v cos alpha times kv sine alpha, because the g's cancel in there. And on the bottom, I've got k lots of g plus kv sine alpha. Now you can see there that the k's will cancel, and I'll have v squared. Now remember, 2 sine alpha cos alpha is equal to sine of 2 alpha, and that's what they want. You can see they've got a sine 2 alpha there. So I need to put a 2 in here somewhere, so that means I need to put a 2 in the bottom as well, just to balance it up. All right, so I'm using that 2 and the sine alpha and the cos part. So I'm using all that part to get the sine 2 alpha, and the only part left is v squared. So I've got v squared sine 2 alpha, and on the bottom we've got 2g plus kv sine alpha, which is what we wanted. All right, so that's there. So that one's just lots of algebra, so good one to practice.